Welcome to Learn Extra. This is grade 11 maths and I'm Katleho. Don't worry, Indiana and Ty are at the back. They haven't left us. Tonight's show is brought to you by Liberty. Thank you very much. Tonight our topic is linear functions and parabola with Natasha. She will be taking us through it. Please only call and send us questions relating to this topic. If you stick with us throughout the year, we will eventually get around to the topic section that you're having difficulty with. Next week, our topic will be hyperbola and exponential graphs. Lots of you have been asking questions about our schedule. So if you are in a group, the topic next week is hyperbola and exponential graphs. The show tonight will start off with a lesson on linear functions and parabola. Then, after a break, we will work through an example or two. Then lastly, we will tackle all of your questions on the topic. There are lots of ways to get through us, guys. Our Facebook page is facebook.com/learnextra, and our Twitter handle is @learnextra. So while you're watching, shoot questions off to us, and we will get around to them in the third part of the show. I do have a Casio calculator to give away tonight to one of the best questions posted on Facebook. We will announce the winner tomorrow on the page. After the break, we will be back with Natasha. Thank you very much. We'll be right back. Welcome back, guys. I hope you got your glass of water and something to eat. Natasha, over to you.
Hi guys, and welcome to grade 11s. It's been such a long break, so I hope that you're all ready and you're relaxed and you're ready to get stuck into functions. Now, if you were watching earlier when Dina was busy with the grade 10s, she looked at the basic functions. So we're going to go a little bit further and remind you about that work, but really just look at the functions, specifically looking at linear functions and parabola. So we're going to look at those two functions today. So let's get to it. Now, guys, when we look at linear functions, right, we have actually done a lot of that work in analytical geometry. In fact, I have actually done a session with you previously before the holidays where we looked at linear functions in lots and lots of detail. So really what I'm going to do today is give you a quick summary about those straight lines, just remind you what we did before and look at a quick example. So linear functions we're going to go through really, really quickly. So if you are stuck, please send Katleho your questions on Facebook and get me to stop and go over whatever it is that you're not understanding. All right, so let's have a look at the linear functions. Okay, I'm just going to try and get to the next page. All right, guys, let me move over this way. There we go. Okay, so just to remind you of some of the functions that you did before, linear functions, your basic straight line has the equation y is equal to mx plus c. All right, you'll also remember that you can use y minus y1 is equal to m times x minus x1. And guys, what that will help you to do is to find the equation of the straight line if you are given a point and if you've got the gradient. So we can use y minus y1 is equal to m times x minus x1. But when you multiply all of that out, you will get back to y is equal to mx plus c. Okay, another important point for you to remember is parallel lines have equal gradients. Okay, so if you have two lines, they don't touch each other, they're parallel. Remember, parallel lines never meet. Okay, so two lines that are parallel to each other will have equal gradients. It's just some of the terminology that you need to remember in order to, when we do those harder questions, you need to call back all of this theory. Okay, another thing you need to remember about gradients is that the product of the gradients of perpendicular lines is equal to -1. So, let me show you what we mean. So if I have line AB perpendicular to line CD, if I know what the gradient of AB is, I know then, because AB is perpendicular to CD, that the product of those gradients will be equal to minus 1. So for example, if the gradient of AB is equal to a half, then the gradient of CD would have to be negative a half, because a half times negative a half gives you negative 1. Okay, so that's some of the theory you need to remember. The other thing that we're going to just remind you of, once again, you have done this in detail in analytical geometry, is that if you want to find the angle of inclination, so say I have the x-axis and the y-axis, and I have some straight line sloping towards the right. If I want to find the angle of inclination between those lines, so that angle theta, all right, then all I got to do is say that tan of theta is equal to the gradient of this line. So whatever the gradient of this line is, I equate tan of theta to that gradient and then solve for theta. Remember, your angle of inclination is always the angle that the line makes with the positive x-axis. So we're always going, sorry, let's just undo that. We're always going towards the positive x-axis. We're always measuring angles in that direction. Okay, so that was just really a quick summary of things that, as I said, we have done before. But if you have any questions, if you are a bit stuck with other concepts that I haven't touched on here with straight lines, please drop us a note on Facebook. Okay, we're going to look at a question now. All right, we have to determine the equation of the line parallel to, and they give you the equation 3y minus 2x is equal to 6, and they say that that passes through the point 9 and minus 1. All right, so let's have a look at that. So what we're going to do, guys, is we're going to call the one that they gave us, this 3y minus 2x is equal to 6. Let's call that the old equation. All right, so 3y minus 2x is equal to 6. That we'll call the old equation. All right, and what we have is we have another line that's parallel to this line, but it passes through a different point. Now that's important. The lines are parallel, but, so if we draw it, so what that means is that they have equal gradients, but they don't have the same points. So this point 9 and minus 1 lies on the one line, the new line, and the old line, we don't know what points lie on that line, but whatever points lie on the new equation, the one that we're going to find that's parallel to the old one, those points are going to be different. Okay, so the only thing that's the same about these two are that they have equal gradients. All right, so how do we find the gradients? I have 3y minus 2x is equal to 6. Okay, we need to rewrite this in standard form. So that means take everything over to the other side. So I get 3y, everything that doesn't have a y in it. I want to write this in y is equal to mx plus c form. So I've got 3y is equal to 2x plus 6. So we divide through by the 3 because we want to get it in that form. Y is equal to mx plus c. We don't want the 3 attached to the y on the left hand side. 6 divided by 3 will give me 2. Okay, so guys, if it's in this form, hopefully you can see that we can just read the gradient. The gradient is going to be 2/3. That's the gradient of the old line. The gradient of the old line is 2/3, and the gradient of the new line, because they have told us that these lines are parallel, the gradient of the new line is also going to be 2/3. Okay, so we had to rewrite, let's just recap what we did. We had to rewrite the old equation that they gave us to get the gradient that is exactly the same as the gradient of the new line. But we aren't done, because remember, they ask you for the equation of the new line. And we know that the new line passes through the point 9 and minus 1. So therefore, remember, we've got a point we've got the gradient, so I can use that equation that hopefully you are all quite familiar with from analytical geometry. Y minus y1 is equal to m times x minus x1. Okay? Y1 will be the y value that we've got, which is minus 1. X1 will be the x value, which is 9. And m is obviously your gradient, which you've worked out to be 2/3. So it's going to be y minus, remember to use brackets here, is equal to the gradient, which is 2/3 times x minus 9. Alright, so I'm going to get y plus 1 is equal to 2/3 x minus 9 times 2/3 will get 6. Alright, so we've got y plus 1 is equal to 2/3 x minus 6. Therefore, y would be equal to 2/3 x minus 7, bringing the constant over from the left-hand side. Alright, so guys, that was just a little recap really of what you've done on straight lines. The other work that you do on straight lines becomes quite involved, where they mix them together with parabolas, and then later next week with exponential graphs and hyperbolas and all that kind of thing. So it does become quite involved, and they're never really quite the simple. And another thing to remember is that when you deal with straight lines, they often put this in analytical geometry in application of quadrilateral. So you need to know straight lines really, really well for analytical geometry. All right, and what we're going to do now is quickly cross over to Katlego and see how she's doing on her first day and if she's ready for an ad break.
Okay, guys, we'll be going to an ad break. Wow, thank you so much for the welcome. We're very, very, very excited to be back. It's great to be back. And thank you for all your questions and comments coming through. It's very exciting. Don't worry, Indiana is around. She's not going anywhere. We'll be going to the ad break. Welcome. Welcome back, guys. Thank you for all your questions that you've been sending. Hope you had a great break. I am very happy to be here. It's very nice to be with you guys. Thank you, Lena. And we'll hand it over to Natasha.
All right, guys, welcome back. We want to look at quadratic functions right now, but unfortunately my board seems to be stuck. So I'm not going to be able to show you much, but what I'm going to do is just quickly explain the theory behind what we're going to do, and hopefully we'll be able to get this board running. All right, so the standard form of a quadratic function, and what you guys know it more similar, the term that you're more similar with is parabolas, okay? And parabolas have the standard equation y is equal to a times x plus p squared plus q. Now sometimes your teacher, instead of using x plus p squared, she might put in x minus p squared, which is fine. It's really going to give you the same thing. What you've got to be really careful about, though, is your signs. Whether you're using x plus p in that bracket or x minus p, either way is fine, but you've just got to be very, very careful when you work out your turning point that you're using the correct sign for p. Okay, so that's the thing to be aware of there. All right? And what really happens with y is equal to a times x plus p squared or x minus p squared plus q, that's different from what you learned in grade 10, is that we're taking the graph y is equal to ax squared. So if you remember, okay, I think that's a little bit small, so I'm going to try and draw that slightly bigger for you. If you remember from last year, the graphs that you dealt with sort of looked like this. All right, unfortunately this pen is not playing ball with me today, and I think let's just quickly take a break at Leko, because for some reason there's gremlins on my board.
That's okay, Natasha. We'll take a break, guys. Hey, you can sneak in a chocolate or two in this break. Please also remember to send in all your questions, and we'll be right back. Welcome back, guys. So, Sinatemba, thank you so much for what you just asked. Sinatemba asked, fellow mind centers, when you do maths, do you practice it or ask someone to explain it to you, or do you just study it? Kashifa, thank you so much. You're such an inspiration to everyone. You were telling everyone to practice, guys. And when she doesn't understand, she asks questions. And remember, no question is a stupid question. Every question can be answered. And we have Natasha, and she's fantastic. Thank you, guys. Thank you so much for your questions.
Katlego, I'm going to come over here and see if we have any questions that we can help our mindsetters with. Has anyone
I'm just going to check.
anything?
Give me a second. Abishai has asked y equals 2.
Okay, Abisha, well done. You've answered the question. The answer is y is equal to 2/3 x minus 7. That is excellent. Well done. And guys, remember, if you have any questions, as you saw before the break, I was about to start parabolas. So if you know already that you have a certain problem with parabolas, now's the time to send it in before we start doing questions and you get all confused in that. So send them in now. All right, is there anything else?
Yes, I'm just checking. Wow, everyone's answering the question, guys. This is so great.
Well done.
Let me see if there's any other questions. Dimple. Dimple says that she's confused here. If the product of the gradients of a perpendicular line equals -1, then why are we saying that y equals 3 divided by 2, I think she said?
Okay, Dimple, I think you didn't get that question down correctly. In that specific example we did, the lines were not perpendicular, they were parallel. So when we found the equation of the old line that they gave us, it was y is equal to 2/3 x plus whatever the value of c is. And so because we had parallel lines, the gradient of the new line would be 2/3. If, however, they said that the lines were perpendicular, then the gradient of the new line would be -3/2. That's when we'd flip it over and say the product of the gradients is equal to -1. Okay.
That's fantastic. And Lebogang also has a question. And Kashifa and Mohosi have been answering. Guys, well done. Thank you so much for helping each other. Lebogang asked, what if it was 3y minus 2x plus 9 equals 6, and passing through the point 9 and -1?
It's pretty much exactly what we did, Lebogang. All you've done there is you've introduced another constant. So all you would do is take the 9 over to the right-hand side, bring all the x's and everything to that right-hand side, and then divide both sides by 3. So it's really exactly what we were doing before. You've just added a constant, so now you'd need to subtract it on the other side. But it's really similar to what we've been practicing so far. And guys, as I said before, we were planning to do quadratic equations and parabolas today, and hopefully we were able to get to that. But if you have any questions that you would like us to answer about parabolas, please send it through on the Facebook page. Remember, with parabolas, we're dealing with the equation y is equal to a times x minus p squared plus q. And what happens with that graph is you take the original graph that you learned in grade 10, which is y is equal to ax squared, and you either move it p units to the left or to the right, and then q units up or down. So the p and the q really tells you if the graphs, or how much the graph's moving to the left or right or up and down. All right, so we will hopefully get to some of those questions a little bit later on, and I think we should take another break for now.
Yes, we will. Thank you, Natasha. Guys, thank you so much. Keep sending your questions, and we'll be going to an ad break. Welcome back, guys. Remember that our show is sponsored by Liberty. Thank you very much. Guys, remember that mindset is getting bigger and better, and we are loving it. Natasha has so many more questions to answer for you guys, and thank you so much for sending them through. We have a question by Lena. Lena asks, how does the value of A affect the parabola?
All right, Lena, so we were actually going to talk about this, so I'm glad that you brought it up now. Remember, the defining equation is y is equal to a times x minus p squared plus q. The value of a in front of that square bracket tell you if your graph is going to have a minimum turning point or a maximum turning point. Or the easy way to remember it is whether it's going to be a smiley graph or a sad graph, okay? If the value of A is negative, so if A is less than 0, you're going to have a parabola with a maximum turning point. So in other words, if you think about a sad face, it will have a sad face with a maximum turning point. And the way I like to remember it is it's got maximum problems, so it's sad. Okay, so if you have a negative A value, you have a sad face parabola. If A is positive, so if you think about you're positive, you're happy, you've got minimum problems. So therefore, the graph of your parabola will be a smiley face. So nice question, Lena, and it's one that everyone needs to remember. One of the first things you do before you actually sketch a graph is you look at the value of A and you decide whether it's going to be a minimum turning point or a maximum turning point. So a really nice question. Is there anything else?
Yes, there is. KB asked quickly, where is the quadratic function equation derived from?
All right, KB, that's quite a lot of work. And the theory, if you would like to know it, you can go to your school textbook and have a look at it. But the equation that we use in y is equal to ax squared plus bx plus c, it's really derived from completing the square. So if you really are interested, it's something that you're not going to be examined on, but for your own background, and if you're really interested to find out, go and have a look at your school textbook and they explain it there.
There's another one. Chifiwa asks, on the quadratic function, does the p always have to change its sign?
All right, Safiwa, I'm not too sure what you're talking about, because P, remember, is the x value of the turning point, and it will definitely change sign, because P could be negative on the negative side, it could be on the positive side, it really can take on any value it wants to. So maybe that is what you're asking. Yes, P can change its sign. In fact, P can be any natural number it wants to be, so it definitely can change its sign. Remember, the value of P tells you whether your graph's going to move horizontally to the left or to the right.
Yeah, and do you want to answer one more by Pakihara?
Okay, well, we're on a roll. Let's do it.
Let's do it. Is it possible for a parabola not to have any x-intercepts?
Nice question, and yes, it is. It's possible for it. Think about when you did some of your graphs for the very, very first time when you learned how to do parabolas. They all turned on the y-axis, and they turned away from the x-axis, and that means that it had no x-intercepts. So yes, it is definitely possible to have a graph with no x-intercepts. What it means is that you'll have a graph that either turns away from the x-axis, so above the x-axis, or below the x-axis. Okay, so nice question. It is possible.
Thank you very much for your question, guys. Natasha, I think your board is ready and on.
Yes, guys, so finally we can get through to some of our questions. Let's have a look. Okay, and I think I'm going to try and step onto this side. And let's just okay, it's still not working, but I'm going to go through the theory anyway, and hopefully you guys are sending some really nice questions through, so hopefully you'll bear with us and you'll send us more of those excellent questions through. Remember that y is equal to ax, the equation we're dealing with here, I'm just going to try and write and see if it works. Y, okay, let's try that again. Alright guys, unfortunately I'm not having any luck there, so I'm so sorry about that, but you guys have been great on the Facebook page, and if you have any more parabola questions you would like me to answer, please send them through. Some of the things I'd like you to remember is that when your equation is in the form y is equal to a times x minus p squared plus q, p and q are the x values and the y values of your turning point. The p corresponding to the x value of the turning point, and the q corresponds to the y value of the turning point. Okay, so that's important to remember. Another thing you need to remember is that your equations aren't always given in that form, y is equal to a times x minus p squared plus q. Sometimes they're written out like this. Okay, so it's expanded into ax squared plus bx plus c. It's written in the standard form. And in that case, there are two ways that you can approach sketching this graph. You can either complete the square. Remember, you've already learned how to complete the square in previous sections. You can complete the square and get it into the form y is equal to a times x minus p squared plus q, and you can work out your turning point straight from there. Or you can use this formula x is equal to minus b over 2a, and then take that value for x, substitute it back into the equation, and work out the y value. Okay, so that's another way you can work out the turning point. Incidentally, both those ways will give you exactly the same answer. All right, so x is equal to minus b over 2a. All right, so x is equal to minus b all over 2a. That is also going to give you the axis of symmetry, or the p part of your turning point. Once you've got that value for x, substitute that value into your equation and work out the corresponding y value. But either way, you're going to end up with p and q being the values of your turning point. Okay, so you always end up with the same values of p and q, whether you're doing it by the axis of symmetry, getting it straight from x is equal to minus b over 2a, or if you are completing the square. All right, I'm going to quickly do an example with you because thank goodness I've been able to get a blank page. Okay, the question I'm going to do with you is the very last thing we talked about. I've got the equation y is equal to x squared minus 6x plus 5. And we want to sketch this graph, but remember, you can either do completing the square or the other way to find the turning point. So that's what I really just want to show you, that it works out exactly the same way. Doesn't matter which method you use. So if I'm using x is equal to minus b all over 2a, all right? Remember, b is the coefficient of the x value. So in this case, it's going to be minus 6. Remember to put it in with your sign. So it's going to be y is equal to minus. Okay, our pen decided to run away there. Minus, try that again, times minus 6 all over. And the value of a is just 1. Remember, that's the coefficient of x squared. So that's just going to be 2 times 1 is 2. And I get negative times negative is going to give me positive 6 divided by 2 will give me an answer of 3. At this point, if you are using this method to determine your turning point, you will take that value of 3, substitute it back into your equation, and see what you get. So let's have a look. So remember, I'm putting the 3 into the value of x to see what I'm going to get for the y value of my turning point. All right, so it's going to be 3 squared, which is 9, minus 6 times 3, which is 18, plus 5. 9 minus 18 would give me minus 9. Minus 9 plus 5 is equal to 4. All right. Now, guys, remember, you can also do this by completing the square. So we're taking exactly the same example, and we're just going to complete the square and show you that you get the same turning point. You don't, incidentally, I need to mention this because, sometimes people get confused and they think, but now, do I have to do both ways in the exam? No, you don't. Your teacher can sometimes ask you to find the turning point by completing the square, and then you'd have to do it that way. But when you are sketching a parabola, if it's given to you in expanded form, you can choose either complete the square or do it by this method. They'll give you exactly the same answer. All right, so if we complete the square, remember our equation here was x squared minus 6x plus 5. So if we complete the square, remember the first thing you do is divide through by the coefficient of a, which in this case is 1. So I'm just going to get y is equal to, if we take out 1, nothing's going to change, so we're not going to show that step. Then we say keep the x squared, find a half of the coefficient of the b term, and you add it and subtract it in the same sum. This sometimes can be confusing, so if you can't remember how to do this, just go back to your quadratic equations and revise. All right, so we find a half of the b term. A half of 6 is just going to be 3. We add that squared. So it's going to be plus 3 squared. And then we minus the same amount squared. All right, and I've just seen that I've done a little mistake here. In the top, when we went 9 minus 18, that gives us minus 9. Minus 9 plus 5 would give us negative 4 there. All right. Okay, so let's work this out. We're going to factorize the first quadratic part of it. So we get x minus 3 all squared plus 5 minus 4. 5 minus 9 will give us negative 4. So guys, what you can see from that is exactly the same thing that we've shown you before. Your turning point is going to be 3 and minus 4. And if you did x equals minus b over 2a and worked out your turning point that way, you get to exactly the same answer. Once you've got your turning point, remember you need to have seen what was your shape. Here we were dealing with a positive value of a, so we're going to have a smiley graph with minimum problems. So that's the kind of graph we're looking at. All right. And once we've got the shape, we've got the turning point, the other thing that we need, and you always work these out no matter what graphs you're dealing with, you need your x and y intercepts. So work out the x and y intercepts. Remember, to work out your x-intercept, you let y be 0. So we have x squared minus 6x plus 5. We let y be equal to 0, and we factorize and solve for x. So we get x minus 5 times x minus 1 is equal to 0. Therefore, x is equal to 5, or x is equal to 1. Those are our two x-intercepts. We just need our y-intercept. To find the y-intercept, remember you let x be 0. So you substitute 0 wherever you see an x, and you'll get your y-intercept is 5. So now we can sketch the graph. We know that, okay, we know what our turning point is, we know what our x and y intercepts are, and we know that it's going to be a graph with a minimum turning point. So let's plot those things down. Remember, your turning points were, if we go back up there, your turning point was 3 and 4, and your x-intercepts were 5 and 1, and your y-intercept was 5. So therefore, we've got an x-intercept of 1 and 5, a y-intercept of 5, and we know that our turning point was 3 and minus 4, which is somewhere down there. So all you're going to do, if I can do it, let's just quickly undo that. All we're going to do is join those points. Woo! Okay, not quite like that. Let's try that one more time. Finally, success. Okay, so that's the graph you're going to have. You can see it's got a minimum turning point. We put down our x and y intercepts, and you would usually denote your turning point on the graph as well. All right, so guys, I'm so sorry that today we weren't able to get everything exactly looking the way and perfectly like we normally do, but I hope that you all understand what's going on, and if you have any questions, please post them to our Facebook page. Katleho, I think we're going to take a break.
Yes, we'll be taking a break, guys. Thank you so much for your questions. Remember that we can't answer each and every question, but I'm so glad to see you guys helping each other and sending all your questions through, especially when we're having the little gremlins attack our board. Make sure you get hydrated and something to eat. Let's go to the break. Welcome back, guys. I'm reading all the answers here, and you guys are on the ball and sharp today. It's very nice to see. It's very nice to see all the questions and you guys helping each other and pulling through for each other. This will help you throughout the year, which is fantastic. And Natasha will be asking a few more questions. Over to you, Natasha.
All right. Okay, guys, what I want to do is I've had a look at the page, and some of you are concerned that we're not getting around to all of your questions. Unfortunately, we don't have time to get through all of them, but we're going to try and answer the general ones that everyone has problems with. I also want to very quickly go over this question that we did, because some of you seem to be a bit confused about where we're getting the points from. So that's all we're doing, is just really going to look at some of the general questions you sent through, and then just going over this for the last few minutes. One of the questions that I saw on the page was, does the value of P affect the shape of the graph? And no, it does not. Remember, P is your turning point, and A, which is the letter in front of the brackets of your entire quadratic equation, determines the shape of the graph. So the value of A, which is your coefficient of x squared, or if it's in the other form, it's the number in front of your bracket, that determines the shape of your graph. Your P just tells you the horizontal shift in the graph. So is it either going to move P units to the left or P units to the right? That's all it tells you. Okay. And I want to quickly look at this question. Remember, we looked at this, y is equal to x squared minus 6x plus 5. And I showed you two different methods to work out the turning point. The one method was to use x is equal to minus b over 2a. If you do it in that way, once you get your axis of symmetry, remember the axis of symmetry is the x value of, or the x coordinate of your turning point. All right? So once you've got that x value, you substitute that back into the equation, and we saw, and we worked out, that our turning point, the y value of the turning point, was minus 4. So that was the one method. And then I said to you guys that the other method, and sometimes teachers may say, guys, complete the square and determine the turning point. Then what you would do is you take your equation, x squared minus 6x plus 5, and you'd use the rules that you learned for completing the square back when you were doing quadratic equations. You'd use those rules to complete the square, and what you see is you get exactly the same turning point, 3 and minus 4. Once you've got the turning points of 3 and minus 4, you also need, and someone was confused about where does this 5 come from and the 1 and all of that, you also need your x-intercepts, because remember, your graph doesn't just turn, it also cuts the x-axis and the y-axis. And the intercepts here we worked out was x had a value of 1 and 5, and then your y-intercept was 5 as well, and it turned at your turning point. So I hope that that clears up whatever problems you're having with this specific question. And guys, that is it for today, but please remember that next week we're dealing with hyperbola and exponential graphs. So if you have any questions about that, send them in to Katlego.
Thank you so much for today, guys. It was a fantastic show, and you guys made it all worthwhile and special. Thank you so much. Remember that we are giving away the Casio calculator to the person with the best questions, and our show is sponsored by Liberty. And thank you so much, guys. Keep sending your messages through. Remember, our Facebook page is facebook.com/learnextra, and our Twitter handle is @learnextra. Thank you so much for a special show, guys. Keep helping each other, keep pulling through for each other, answering each other's questions, reminding each other of which question was which and which answer was which. Thank you very much, guys. Enjoy the next show. Remember, Indiana, we're back with the grade 12s. Thank you.